focus today is on conditional statements. And admittedly, this is going to be a longer video. I don't want to rush through things. Our objectives are to be able to identify, write, and analyze the truth of conditional statements. Backtracking a little bit, we'll notice that the statements we were using with our warm-up, these are not conditionals. These are just some of the bits and chunks that we will use to put conditionals together. We'll see how that structure develops in a moment. But we want to be able to identify, is this statement true or false? Yes or no? We will also want to be able to rewrite them. After we develop a conditional, there are some related statements, inverse, converse, and contrapositive, and we will see how to write them as well. Now, here is our list of all the vocabulary we're going to use. Each one of these pieces does play a role, and I can't tell you that there aren't any here that aren't important. Each one of these are things that you are expected to learn. We are expected to be able to use and understand each one of them. Now, the main structure behind what we are working with, a conditional statement. Conditional statements are a lot of times also called if-then statements, because we're setting up a set of conditions. If this thing is true, then we can conclude something else. In terms of the vocabulary, the entire thing here that I have written in red, that is the conditional statement. If Jalen runs cross country this weekend, then Jalen is going to win. That's a conditional statement. Now, I'd like to ask you, Jalen, do you run this weekend? Yes.
Yeah, I will.
Because Jalen is running, then we can say he's going to win. Now, do we know right now if that's true or false overall? All right, Jalen's saying false overall. You need more confidence there, man. Now, some other components that we have to note. This first statement here, this is the hypothesis. Same term that you would have from your science classes. If the hypothesis is true, then we are going to make a conclusion. And I would like to note, for your notes, you probably should draw the Venn diagram. Having these pieces for all the stuff written in words is less important than having you understand this. I'm not saying that you shouldn't know the vocabulary. You should. You should certainly know what the words mean. I just don't really care if you have it like, oh, this is exactly how the written definition is. It's more important to understand it than to memorize it. And I'll pause here while you catch up with the writing. Now, I would like to point out the notation that we have here. The symbols we will use to write out an if-then statement. The hypothesis implies the conclusion. And it doesn't really matter how you draw the arrow. A lot of textbooks like to use this symbol for the arrow. Just as long as it's some kind of arrow, we're good to go. If I wind up drawing different ones, I want you to be aware that it doesn't matter as long as it's an arrow. All right, so our first skill. We have some if-then statements. What is the hypothesis? What is the conclusion? If today is Thanksgiving, then today is Thursday. If today is Thanksgiving Day, the entire thing is the hypothesis. Then today is Thursday. That whole component is the conclusion. Something I'd like you to be careful about occurs in B. What is the hypothesis for B? Sometimes you'll encounter students say a number is a rational number for the hypothesis. That's not correct. The location of the word if is critical for us. The hypothesis is always tied to the word if. And because of the way English works, I mean, start thinking of Yoda. To Tatooine we will go. You can have the subject of a sentence at the end, just like Yoda talked. Well, here we go. We have Yoda math. This one, if it's an integer, that's the hypothesis. Then it's a rational number. This piece is the conclusion. It is possible to have the conclusion written before the hypothesis. That's just the way English works. Now, using your marker boards, I'd like you to identify the hypothesis and conclusion here. I'll pause the video while you do it. And checking your work, people correctly identified the location of the word if to get the hypothesis, leading us toward the conclusion. And I actually like what Shailene did really well, because she even tied it, instead of using H and C for hypothesis and conclusion, she started tying it to the symbolic logic P and Q, leading us towards P implying Q. That was just really cool. I didn't expect to see it, so kudos, Shailene. Now, we've looked at two different structures. We have looked at if hypothesis, then the conclusion. This is the most common way that they will be written. We'll see it the most frequently, but as we've noted, it's also not the only one. We also saw Q for the conclusion, if P. Those are the two types that we've seen already. There are others. Instead of using the words if then, we could also use just the word implies. Jalen is running cross country this weekend. Implies Jalen is going to win cross country this weekend. You'll notice it's not set up as if then, but it's still the same logical thought. Another one we could use, just get rid of the word then. If Jalen runs cross country, Jalen is going to win. We don't have to use the word then, but the word if does play a role there. Now, we'd like to be able to write out a conditional statement. So we're trying to translate this piece. An obtuse triangle has exactly one obtuse into something that fits an if-then statement. What's the hypothesis? An obtuse triangle has exactly one obtuse angle. This piece here is our hypothesis. If a triangle is obtuse, of course that's not the only way that we can phrase it, but you see how the idea is the same. If a triangle is obtuse, then it has exactly one obtuse angle. You see the structure here? We're translating it from a statement of fact into an if-then statement. In terms of a Venn diagram, it has this similar structure. And we saw the Venn diagram already in our notes. if an animal is a blue jay, then it is a bird. We saw previously that when it comes to a Venn diagram, one option inside another is how we can identify the hypothesis and conclusion. Okay, let's write a conditional statement here. And this is one that I'd like you to do on your marker board. All right, looking at your work, I am seeing the structure. People are identifying the beginning part will serve as our hypothesis if two angles are complementary, then they are acute. There's our structure. All right, so we started off by looking at just the structure behind a conditional statement. The component that we're most concerned with is evaluating whether it's true or false. The truth value is going to be based on identifying the truth values of individual pieces. The hypothesis can be true or false. The conclusion can be true or false. And we will have to look at them to figure out which one, how it all comes together. For instance, is this overall true or false? And I'm looking at the symbolic logic for P implies Q. And so we have to start by identifying the hypothesis. What is it? If this month is August, there's our hypothesis. Then the next month is September. This is the conclusion. We're going to start here. Is it August? No. So right now, this is a false statement. The hypothesis is false. If it's August, and it's not. So we have a false statement implying then the next month is September. Well, right now, is next month September? No. So that is also false. Even though we have it so that the hypothesis is false and the conclusion is false, the overall statement is true. Here's one of the pieces that you need to be aware. I want you to write this down. This is something you need to remember. False implies false. That is overall true. That is something that you need to recognize. We will look with more examples into this relationship and other relationships further. Now consider this example from geometry. If two angles are acute, then they are congruent. So we'll put this down. Here's one acute angle. Here's a second acute angle. So right now, true or false? If two angles are acute, do I have that? Yes. My hypothesis is true. Then they are congruent. Look at them. Are they actually congruent? No. So my conclusion is a false statement. The structure we have right now, true implies false, that is overall false. This is another piece that you desperately need to know. You have to understand, because it serves as the basis behind a lot of our work with proof. True implies false. makes the overall conditional false. And since we needed to have a counterexample, right there it is. I have a pair of acute angles. They're not congruent, and so this set of pictures is my counterexample showing that the statement is false. As weird as it seems, true implies false is the only way for this to be overall false. When we start considering other statements like if I make the Olympics, then I will win the gold medal. Well, let's start by considering this with my hypothesis. Is there any way I'm making the Olympics? Nope. Nope, I'm not going to make it. So we instantly have a false statement implies, then I'm going to win the gold medal. Is that true or false? You don't know. How can you prove me wrong? If you were going to provide a counterexample, the only way that you could provide a counterexample is with this. The only way that you can prove something false is by showing this is here. A true hypothesis mixed with a false conclusion is the only way to mathematically prove something is wrong. There's no way you could ever put me in the Olympics. It's not going to happen. And since the false hypothesis will never, ever happen, there's no way for you to actually prove me wrong. It doesn't matter what this second part is. It doesn't matter if it's true. It doesn't matter if it's false. The statement is overall true. And a lot of times this freaks students out. Because you're looking at something that begins with a lie but is overall true. It's hard to accept that for a lot of people. But that's the way it is. Any statement, any biconditional that begins with a false statement is overall true. And because we have no way of figuring out if its conclusion is true or false, because there's no way to figure anything out, in math, we avoid these things. When we go and read through our textbook, whenever we have our theorems, whenever we have anything, it's going to be presented. If this stuff is true, then I get this conclusion for free. And we're always going to be concerned with the instance where we have a true hypothesis because false hypotheses are worthless. We can't do anything with them. We're discussing the structure now. We're discussing the truth values now so that when we start identifying and focusing heavily on this structure later on for the course, it'll make more sense. Let's analyze one more truth value. And I would like for you to do this one on your marker board. All right, so when we look through it, we can quickly see our hypothesis. If an even number larger than 2 is prime, that's false. The only prime number that's even is 2. And so there is no bigger even prime number. At this point, I could stop. I don't even care about the rest of it. I have a false hypothesis. A false hypothesis instantly makes the overall statement true because there's no way to prove it's wrong. Now, when I was checking your work, I saw a lot of people continue and recognize that the hypothesis is false also. False implies false is overall a true statement. False implies true is overall a true statement. That's why we didn't care what the hypothesis is. A lot of you did it with the work anyhow. That's fine. It was just extra work that wasn't needed. As soon as you see a false hypothesis, it is overall true. So just want to emphasize once more. True implies false is the only way to have a false conditional. True implies true is overall true. False implies false is overall true. False implies true is overall true. The only way for a conditional to be overall false is with the top instance. A true conditional implying a false conclusion. That's the only possible way to be overall false. Now, another piece of vocabulary we need is negation. Negation just means we're going to change the truth value. For instance, really simple ones like right now, is this true or false? That is a true statement. What would we have to do to change its truth value from being a true statement to a false statement? One word. Stick in the word not, and we've changed its truth value. That's what negations do. A negation will change the truth value, whether we're changing it from true to false, or we change it from false to true. For instance, 3 plus 5 equals 9. Right now, that's false. What would we have to do to change it to be true? And this is a piece that you want to be careful about because we don't change numbers. If we were to change this into 4 plus not 5 equals 9, that's a completely different statement. It's not a negation of this one, it's a different statement. That would be like saying Javen is on cross country, or Chance is not on cross country. But when we change the person, we're changing the statement itself. We need to keep the numbers the same. And so what could we do to change this Three plus 5 equals 9. 3 plus 5 is not equal to 9. And there's our change. A negation is typically going to just put the word not in there somewhere to change them. It's finding a good, accurate place to stick in the word not so that you change it. Change the truth value. Now, we've mentioned that the basic conditional is set up P implies Q. When we use negations, there are other forms that we can create. If we flip the direction around, Q implies P, this piece is called the converse. Now, besides the converse, there is also the inverse. You see the squiggly we have here? That's the symbol we use for not, or the negation. Not P implies not Q. When we do that, it's called the inverse. And the inverse will have some uses for us, not as many as the converse, but it does have some. And the last one we have is the contrapositive. Because then we have not Q implies not P. The contrapositive will also play a role for us. In particular, it will be important when we are working with proofs. At the end of this video, we will discuss the law of contrapositives, and there's something about it that you should know. All right. Now, before we start looking at these pieces, the last skill that we're going to write, the last skill that we're going to do, is to write down what the converse is, write down the inverse, write down the contrapositive. In order to do that, we're going to start with just this basic piece, just so that we know what statements are true and false. Adult insects have 6 legs unless Hunter has gotten crazy and like ripped a leg off or something. No other animals have 6 legs. So basic facts from biology that we're going to use. Here is our conditional. If an animal is an adult insect, then it has 6 legs. We can already identify this is our hypothesis. That is our conclusion. In order to write out the converse, we know that the converse is Q implies P. All we're doing is writing down the sentence then so that it fits this different structure. If Q, an animal, has 6 legs. If Q, then P. Our original P, the original hypothesis, it is an adult insect. That is the converse. All we're doing are flipping around the P and Q. Now we'll continue to the inverse. The inverse has the structure not P implies not Q. And so this is one where we'll say if, but we need to have the negation of P. An animal is not an adult insect. Then, so we've written out not P. Now we need the negation of Q. It does not have 6 legs. This piece in red is our inverse. Lastly, we need the contrapositive. I'm going to have to scroll down here, create some more room. The contrapositive is not Q implies not P. So we're starting off with not Q. If an animal does not have 6 legs, negation of Q, then the negation of P. It is not an adult insect. Part of our skill that we will practice is just writing the statement down. Nothing more than taking and rewriting the sections so that we will put them in their appropriate place. Now, the last piece we needed for this lesson, there is a piece called logical equivalence. You know how we were saying we had the statement for P implies Q, and it could be overall true or overall false? Without going into the full details why, because that would take us several more minutes, without going into the full details why, if we take the contrapositive, not Q implies not P, the conditional and the contrapositive will always match in truth value. Oh, if the conditional is true, it will guarantee that contrapositive is true. They always match. But if the conditional were false, the contrapositive will be false. They always match. Always. And that finishes up everything we needed for conditional statements.